Okay folks, we are looking at the grade 11 final exam of 2018. The paper, under focus, is the algebra paper, so I'm going to cluster questions together because you guys did rather well in algebra. Okay folks, so please make sure once you've watched the videos and you checked it with whatever you did to like whatever the video is so that we can get something going on the site. Okay, let's go for the first question. The first question says all three of these are asking you to solve for x. Now if you look at how they are what these questions are testing, this we know is a quadratic equation. We just need to uncover it. There's a few problems we need to pay attention to before we start solving. The second question is a quadratic inequation. Okay, these need diagrams to sketch them with. And if we look carefully at the third question you could see there's two brackets that are identical, except for the one is squared, the other one not. So we're possibly going to use substitution there. Let's see. Here, I'm going to start with my restriction. Now, please remember, whatever is underneath the root has to be bigger or equal to naught. Else this equation is problematic. Okay, so if we throw the x over, minus x bigger than equal to minus 5, and finally x is less than equal to 5. But that's not all. In front of this root there's a positive. On the other side of this equation there's an x. That x can possibly make this side negative. So we also have to say that 1 plus x must also be bigger than equal to naught. That brings us to a final restriction for the right hand side of x is bigger than equal to minus 1. Now folks, when you go to a number line, there's minus 1, there is 5. This solution says to the left of 5, it's smaller than. That one says anything bigger than minus 1. You can see where the overlap is. So my final restriction is going to be smaller or equal to 5, but at the same time it has to be bigger than equal to minus 1. Now they can ask that as a question. They would say, show that x is bigger than equal to minus 1 or less than equal to 5 at the end, and less than equal to 5 rather at the same time. That means restrict the values that x cannot be here so that the equation doesn't become non-real. Okay, then we can start by getting rid of our root. Please get yourselves into the habit of doing that. If I square both sides, 5 minus x is now equal to x plus 1 all squared. Now x plus 1, 1 plus x, same thing. Okay, I square out x squared plus 2x plus 1. I collect all the x's to the one side of the equation, so x squared plus 2 plus another one is plus 3x. And then I have the 1 minus the 5, and that gives me minus 4, which is indeed equal to the minus 1. Okay, now to minus 4 rather. Okay, I can now factorize an x and an x, a 4 and a 1. The signs are different. The bigger one is positive. That's positive. This is negative. Therefore x is equal to 1 or x is equal to minus 4. Now minus 4 clearly falls out of the restriction. It's to the left of minus 1. So we are going to say that this is not applicable. It is a solution to that quadratic, but it doesn't apply to this particular question the way it was asked. So the only solution that we use is the x equal to 1. Folks, make sure that you know how to deal with restrictions. Okay, you have to get the third by itself. If this was 5 minus x rooted minus 1, you have to transpose everything that's not connected with the root to the other side. Okay, let's look at b. b gives me a quadratic inequation, so I get x squared minus 3x is smaller than naught. Okay, if I factor this, that's a quadratic binomial. I remove the common factor. I'm looking for where that product is negative. So quickly, my critical points will be where x here is naught and x there is 3. because the x squared has a plus in front of it, will always be positive, go through the root negative, go through the other root to become positive again. What am I looking for? I'm looking for where it's negative. So it's clearly between those two is where x is negative. Notice it's a strict function. So x is strictly less than 3, but at the same time bigger than 0. And there you've earned your 4 marks. Okay, so these were quite straightforward. This you had to play a little bit with what the value of x can be. Now some of you don't do this and you go to solving the equation and then you check it, which is all fine, folks, no problem with that. But if the question paper asks you to show that x is between 5 and -1, which is what they did on the IB paper with the matrix at the end of 2018, then you absolutely have to state your restrictions. Okay, let's look at the third one. We identified that this is a substitution question, so to make it easier, I am going to substitute k with x squared, or x squared plus 2 with k. Then I get k squared minus 2k, throw the 3 over, minus 3 is 0. This factors quite nicely into 2 brackets, 3 and 1. Signs are different, bigger one is negative, so that's negative, this is positive. So finally I can say that, what was k? K was x squared plus 2x plus 1 is now 0, or I'm going to leave some space, x squared plus 2x minus 3 is 0. Now if I look at this quadratic equation, folks, it's very clear that this is x plus 1 all squared, which is 0. So from that component, x is equal to -1, an equal root. It's a perfect square. So it's a root of multiplicity 2, the root of x plus 1, or x squared plus 2x plus 1. Here I can factor x and x, a 3, a 1. Signs are different, bigger, positive. That's a positive, this is a negative, equals 0. So from there, x is 1, or x is equal to a negative 3. Folks, it's 8 marks. It is 8 marks. There is always going to be a simultaneous equation on your paper. So make sure that you can deal with those. Okay, we're still going to look at solving of equations, so we're moving to question 2. Question 2a, solve for x and y. So immediately you know it's a simultaneous equation. So somehow the one is going to be substituted into the other one. Okay, now let's have a careful look here. X has a coefficient of 1, so it's going to make very good sense to isolate the x so that you don't form a fraction. If you isolate the y, then you have to divide by 2. Then you're working with a fraction. You guys have problems working with fractions, folks. Avoid them. I call them the F word of mathematics, fraction. Okay, so let us start and let's isolate the x. X is equal to minus 2y minus 4. This is equation A. If I label that equation B, I tell the reader that I'm taking A into B. Now notice I'm not distributing this. I'm just going to plug the x in and see what happens, and hopefully it cleans itself up nicely. This question here was for 7 marks. Okay, so it should be straightforward, more or less. Let's see. If I plug the x in, I get minus 2y minus 4 minus 1 in the first bracket. Here I get minus 2y minus 4 plus that y plus the 1. That gives me 0. So over here I'm stuck with minus 2y minus 5 multiplied by minus y minus 3. Look at that. Plus 4 minus 1 is minus 3. Minus 2y plus y is minus y. Everything as a negative. So I can remove the common negative there and I have plus 5. I remove the common negative here. I have y plus 3. And the two negatives that I've removed, they multiply out to be positive. A minus times a minus is a plus. Look at how beautiful this is. Y is then minus 5 over 2, or then y will be minus 3. I run back to my equation for x. So x will be minus 2 Be careful now, minus 5 over 2 is y and then minus 4. Or on this side, x rather, not y, x is going to equal minus 2 times y, and y is negative 3. Be careful of the double negative. This question is full of little hiccups that you've got to watch out for. Now this is 2 times 5 over 2. We know the 2's cancel. A minus times a minus is a plus. So 5 minus 4 leaves 1 over there. Here I'm stuck with x is equal to a minus times a minus is a plus. 2 times 3 is 6 minus 4. And that gives me a 2. So it said solve for x and y. So your combinations for solutions will be the point 1 minus 5 over 2, that combination, or the other solution is at 2 and minus 3. Two solutions, a little bit of fractions in there with your answer. Oopsie, I missed you guys over there. A little bit of fractions with your answer, and then we just write our two solutions down together. Okay, so that was for 7 marks. The next question, part B, we're still solving equations, is asking us to solve for x by completing the square in this quadratic. Now this quadratic is 2x squared minus 6x plus k. I'm going to do it for you in 2 ways. The first method I'm going to use is the traditional way to complete the square. Now remember, to complete the square, your coefficient of x has to be 1. We're lucky this is an equation, so we can divide both sides by 2. Okay, so we're going to start with that. We have x squared minus 3x. Now look at this, I'm going to throw it over the equal, and on the other side I have minus k over 2. This is the step that completes the square. Okay, how do I complete the square? I take the middle term, which is 3, I halve it. So I get 3 over 2 here, I get 3 over 2 there. There's my completed square. X minus 3 over 2, all squared, is then 9 over 4 minus the k over 2. Okay, remember they say solve for x by completing the square. Okay, I clean this up a bit, so I get x minus 3 over 2, all squared. The LCD here is 4, so 9 minus 2k. I must times that 2 with a 2 to get to 4. What I multiply the denominator with, I have to multiply the numerator with. So that becomes a 2k. Then finally x is 3 over 2 goes over, plus or minus the square root of this ugly thing, 9 minus 2k over 4. Now you cannot take the square root over that term, but your exponential law tells you the root of a fraction is the root of the numerator over the root of the denominator. So if I combine that, I get plus or minus 9 minus 2k, and all of that is given over 2. Okay, so far it's pretty much straightforward. You just have to work much slower in order to avoid the mistakes. That question was for a beautiful 5 marks. Okay, now they say the hence part of the question. The second part of the question says, hence, determine the values of k for which the roots of 2x squared minus 6x plus k equal to 0, for which those roots are going to be real and unequal. Now if roots are real and unequal, for equal roots, the discriminant for this must be 0. Okay? So we're not allowing it to be 0 because the roots must be unequal. So delta cannot be 0. For real roots, delta must be bigger than 0. Strictly bigger than 0. Okay? They don't care if it's rational or irrational. They didn't ask that. They just said, hence determine the value of k for which this equation are real and unequal if k is a positive integer. Sorry, so in any case, what are they saying to us then by mentioning that k must be a positive integer? they're drawing our attention to the fact that whatever k is there, it has to be positive and it has to be integer. Now there's delta. 9 minus 2k has to be bigger than 0. So what does this mean? Minus 2k is bigger than minus 9 if I throw the 9 over. So what is k? K is less than 9 over 2. Okay, and remember, k at the same time has to be a positive integer. So what are the values for k that's going to make this happen? Any k between 0 and 9 over 2 that are integer. They say to us, determine those values. So k can be 1, it can be 2, it can be 3, or it can be 4. One of those 4 would lie between 0 and this. Remember, this is 4.5. So that's the integer values that will make the roots of this equation be real. Okay, that's your first 2 questions on equations, folks. I hope it made sense to you.